Time is X minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Welcome to the Big Bounce, Scotland's Festival of Physics. And here we are in the iconic, look at that, Barrowland Ballroom here in the heart of the East End of Glasgow. But you can be anywhere you like, and you can join in from anywhere you like. Our next speaker is absolutely riveting, and if you have questions to ask, you just pop them into the little window at the side on the YouTube there, and we will read out those questions and get them answered. Now, this subject is something that's very much now on everyone's mind. It's climate change, and I'm afraid that most of us have the tendency to see those two words together and just do this. However, it is serious, but it is simple, and believe it or not, it's also solvable. So, what we're going to do now is go to an expert who's going to point out that we can do something, what it is, and how we can change things. And it's the fabulous and wonderful Dr. James Rae. James.
Okay, thank you very much, Susan, and thank you very much, all of you, for joining today. It's a real pleasure to be here. I've always wanted to play the Barrowlands as a Scottish scientist, so it's a real treat to be able to do this, at least virtually. So, as Susan said, my message today is a hopeful one. Climate change is something that we know what to do about, and I want to talk you through that with the 3 S's of climate change. The science behind climate change, you'll often be told, is very complex, but really, we can boil it down to something very, very simple. The impacts of climate change, however, are serious, so this is a problem we need to solve, and we can solve it. Okay, so let's dig in. So, climate change is happening, and it's us. Here is one amazing depiction of that. This image shows all of the years from 1850 to 2018. Each year is one of these stripes, and let me show you my slides here. So each one of these stripes stands in for a year. If the global temperature was cold, it's shown in blue. If it's warmer, it's shown in red. And so you can see this amazing, very clear and striking pattern that over the last 150 years ago, we've got warmer and warmer and warmer and warmer. You can see that in these warming stripes. You can see that in graphs like this one, which show this steady rise in temperature over the course of the last 100 years or so. But you will also find people out there who don't believe in graphs and don't believe in thermometers. It's a crazy claim not to believe in thermometers, but these people exist. So you can show them this as well. This is a really striking image of the change in climate that's happening around the world. These are 2 photos taken from the same exact location in Iceland. The one on the left in 1941, the one on the right in 2004. And the striking difference, of course, is that this huge glacier, this massive sheet of ice, has melted right back. And this is a picture seen the world over. So climate change is happening, and spoiler alert, it's us. And the key driver of climate change is the addition of CO2 gas into our atmosphere. So how does this work? We're going to dig into the physics of this in a wee bit of detail, because it is, after all, a physics festival. But I'm not actually a physicist by training. I'm a geologist, and I like to simplify things down a wee bit. So we're going to talk about the physics, but we're going to talk about physics through the medium of dance. So, everyone watching at home, I'd like you to stand up, please. Let's loosen up, loosen off, get those shoulders going, and we're going to talk about the energy balance of our planet, and we're going to dance it out. Okay, so the energy that powers our planet, that powers our climate system, comes to Earth from the sun. And it reaches Earth from the sun as bouncing waves of light. So I want all of you to loosen up and give me your best bouncing waves of light, okay? Right, okay, so we've got bouncing waves of light, and they are flying towards the Earth at the speed of light, and they collide with the Earth. And when those bouncing rays of light collide with the Earth, they transfer energy to our planet. Okay, what's energy? That's one of these kinds of physicsy questions that we could dig deep into. But for the purposes of this talk, and really the nitty-gritty of it actually just boils down to this. Energy is the bouncing around speed of atoms. So our planet, me, you, everything is made up of atoms. And if they've got more energy, they bounce around faster, okay? And that's why, in fact, if you touch something warm, it feels warm because its atoms are bouncing fast. And when you touch it, some of that bounce gets transferred into your fingertips. Your fingertips are speedometers for atoms. And if you touch something warm, you get to feel some of that fast atomic speed of those bouncing molecules. So, a beam of sunlight hits planet Earth, and as a result, the atoms on Earth bounce a bit faster. So I'd like everyone to bounce a wee bit faster. Now, an amazing aspect of energy is it gets transferred from one form to another. And so any bouncing atom can actually radiate back its energy in the form of light again. And because Earth radiates its form of energy as infrared radiation, we get to do a nice wave of light energy again. But this one is going to be a wee bit kind of smoother and cooler and slower. Okay, so your best infrared radiation flying back into space. Okay, so if that was just it, if that was all that our climate system was, our planet would be a chilly minus 15 degrees C. So we'd be a frozen ball of ice in the middle of the solar system. Now, thankfully, that's not the case, because there's something that stops that energy from flying all the way back out to space. And that something is bouncing molecules of CO2 in our atmosphere. Okay, so it's our final dance move, people. I want you to be CO2 molecules. You're going to have one carbon atom, that's your head, and you're going to have two oxygen atoms as your hands. And you can bounce like this. This is one of the ways in which CO2 bounces. And you can also bounce like that. There we go. That's the other way that CO2 bounces and vibrates. Now, CO2 is in our atmosphere. And CO2 has a kind of rhythm that's pretty similar to that of infrared radiation coming out from our planet Earth. And so when that CO2 sees that infrared, it can absorb the infrared, and just like the planet, it starts vibrating faster. So it absorbs some infrared radiation, it bounces faster, and then it can re-radiate some of that infrared back down to our planet. Our planet gets warmer by absorbing that infrared, it bounces around faster, it sends that energy back out into the atmosphere, the CO2 absorbs it again, it bounces faster, it sends it back down to Earth, and by now, our planet, and hopefully all of you guys too, are a lot warmer than we were to begin with. And so, as we add more and more and more CO2 to our atmosphere, our planet gets warmer and warmer and warmer. Now, a wee bit of CO2, that's no bad thing. That gives us a planet that isn't a frozen ball of snow and ice in space, but is the blue planet full of water and life that we know and love. But as we add more and more CO2 to the atmosphere, it gets harder and harder and harder for that energy to escape back out into space. So our planet gets warmer and warmer and warmer. This is just like putting more and more and more layers on. If you were to go out and start going for a run and you put on a big jacket and a hat and a pair of gloves, you warm up and up and up because your body's heat can't escape. This is just the same on a planetary scale. As we add CO2 to the atmosphere, it gets harder and harder for Earth's heat energy to escape. So, is this something new? Is this something controversial? No, it isn't. This is incredibly well established. The first person to figure this out was Fonte Arrhenius, this amazing mustachioed gentleman here. Back in 1896, he worked out how much the planet would warm if you added CO2 to the atmosphere. And he worked out that burning fossil fuels, coal, oil, and gas would add CO2 to the atmosphere, and the world would get warmer as a result. And this is something that over 99% of climate scientists agree on. Okay, this is just it's simple and incredibly well established, and everyone agrees that this is the case. Okay, so we've added CO2 to the atmosphere. How much? Is it a big deal? So to get a bit of a sense of that, we're going to look into our planet's past history. We're going to look at the history of climate change. And we're going to look into the history of climate change during the ice ages. This is something that I do for my research here in St Andrews. So this is a picture of our planet, an image of our planet at the peak of the last ice age, where there's a huge ice sheet on top of North America and a huge ice sheet on top of us here in Scotland. So where I'm standing right now in either St Andrews or virtually in the Barrowlands, I'd have had a kilometre of ice, 1,000 metres of ice on top of my head. So that is an incredibly different climate. Let's look at what CO2 level that climate had. So to do that, we look at these amazing archives of past climate change. This is a tube of ice, an ice core, which we've drilled from Antarctica. Each layer in this ice core represents a year of snow falling onto the Antarctic ice. And if we slice up these years of snow and ice, and we look at them very closely, you can see that they're full of tiny bubbles. And those bubbles contain little fossilized fragments of our ice, of our atmosphere from tens and hundreds of thousands of years ago. So by melting this ice and looking at what gases come out of those bubbles, we can look at the history of our planet's atmosphere. So that's what I'm going to show you on this next graph. We're going to have CO2 concentration on the y-axis, and we're going to have time going forward from 800,000 years ago at the left, so almost 1 million years ago through to the present day. So what you see as you look at these ice cores is this regular pattern of low values, which are associated with ice ages, going to high values, which are associated with interglacials, periods in between ice ages. Now, what have we done in the last 100 years? Let's add that to this graph. So, in the last 100 years, we've managed to get CO2 to go up to 413 parts per million in the atmosphere. Parts per million, that's like if I took 1 million molecules in the atmosphere, 413 of them would be CO2. So you can see, for context, that is, more than the same, again, as was associated with the end of the last ice age. So the last ice age was about 200 parts per million, and it went up to about 300 parts per million, and it did that in about 10,000 years. Over the last 100 years, we've done another 100 ppm CO2 rise. So it's the same CO2 rise as associated with the end of the last ice age, but we've done it 100 times faster. So, the science of climate change is simple, and it boils down to these three facts. CO2 is a greenhouse gas, and we know what that means now. We've worked that out through the medium of dance. It absorbs outgoing energy from the Earth, and it sends it back down to our planet's surface. And so, as you add more CO2 to the atmosphere, which we've done by burning fossil fuels, our planet gets warmer and warmer and warmer. We are blanketing our planet with CO2. And the world is indeed getting warmer. This is another view of that. I'm showing you time going forward through the 20th century. Colder temperatures are in blue, warmer temperatures are in red. And you can see that as we get up to the recent past, our planet gets warmer and warmer and warmer. So the impacts of this change in temperature are serious, and they affect a whole variety of different processes on Earth. I'm just going to talk about two of them because they're two that we can see in quite a striking way. And I'm going to talk about the change that happens in rainfall patterns as our planet warms. So to understand this, it really boils down to one kind of key piece of physics, which is that as you heat up the planet, it gets easier and easier for water to evaporate. And so this, you can think about this a bit like if you had a bunch of pans of water on your stove. As you heat up your stove, that water evaporates. And so in hot, dry places, they get drier and drier and drier. But that water also has to go somewhere. And so that water comes back out of the atmosphere in the wetter places. And it comes back out of the atmosphere in the form of rain. So as you warm up our planet, dry places get drier and wet places get wetter. It's just like turning up your stove and water evaporating out of those pans and condensing and running down the windows where it's a bit colder. And the impact of this is profound, and we've seen this repeatedly and tragically, even now, even already. Sometimes people can think that climate change, well, it sounds bad, but it's distant, it's far off, and in the future. But it's already happening. And so we've seen some horrifying aspects of this already in wildfires burning up Australia, where as it gets hotter and drier, fires become more prevalent and more destructive. But closer to home, that water has to go somewhere, and it falls as rain in wet places like here in Scotland. And so we see increasing flooding already, and this will get worse and worse unless we do something to fix it. So how can we fix it? What is the outlook for our future planet? This is something that I think about a lot, and I've thought about a lot in the last few years because of this guy here. So this is John. He's my 2-year-old now. He's a lovely wee dude, and I think a lot about what the world that John grows up in will look like. So for context, John was born 2 years ago in 2018, and when he was born, the planet was already about 1 degree C warmer. Now, depending on what choices we make about our future energy supply and how much CO2 we put into the atmosphere, John will either grow up in a world that has more and more in the way of forest fires and flooding and higher sea levels and a bunch of these other tragic impacts of climate change, or he gets to grow up in a world that doesn't look too dissimilar from the one that you and I know and love, with these fun furry friends at high latitudes and a stable climate that is the kind of climate that our society has evolved in. So how do we choose if we go into one of these warmer climate states or one that's more similar to the climate that we've grown up in? Well, we can go back to our simple understanding of the cause of climate change. And overwhelmingly, it is the burning of coal, oil, and gas, and the production of CO2 in that process. I mean, this has been historically really useful for us. This burning of coal, oil, and gas has provided energy. But in the process, we've released just an enormous amount of CO2 into the atmosphere. We are essentially dumping CO2 into the atmosphere like it's an open sewer. And so we have to choose. Do we keep dumping CO2 into the atmosphere, or do we imagine a world that looks different? Can we imagine a world where we don't use the atmosphere as an open sewer and where we get our energy in a clean and zero carbon fashion? And here's the really good news. We can do this. We know exactly what the problem is, and so we know how to solve it. I'm going to give 3 examples of what we can do to solve this problem, but all of them really revolve around getting less CO2 in the atmosphere. Okay, so the first one is clean energy. And there is incredibly good news here. So clean energy is growing faster than anyone possibly could have predicted. And this is something that we can be really proud of here in Scotland. It's actually a rare advantage of the Scottish climate and Scottish weather. Not the capacity for solar energy, I'm afraid, but our capacity to generate electricity from wind power and from hydroelectric power. So already in Scotland, clean energy accounts for 3/4 of our electricity. That's absolutely incredible, right? And the amount of renewable electricity in Scotland has tripled in the last 10 years. So this is good news for our planet. It's also good news for the Scottish economy. Right, this has a £5 billion turnover and employs almost 20,000 people. So we want more of this, and it is going in the right direction. And it is making a difference. So across the UK, already, CO2 emissions have fallen to their lowest level this year since 1888. Okay, so this is really, really making a difference. How can you be part of that? Well, here's one really simple, straightforward and easy thing you can do. Switch your energy supplier to a renewable energy supplier. Here are 2 examples, Bulb, Octopus Energy. There are a bunch of them out there. You will save CO2, but you will also end up saving money. These tend to be cheaper than the traditional big suppliers. Okay. The next thing that you can do about climate change, and it's an easy one again, is just eat a bit less meat. I'm not saying you have to go vegan. I'm not saying you have to never have a bacon roll or a steak ever again, but just a bit less meat, because cows emit an enormous amount of greenhouse gas, funnily enough, when they burp. So if we put together all of the cows on the planet into one country, they would have the 3rd highest greenhouse gas emissions out of any country. So we probably just could do with slightly fewer cows on our planet. And a way that you can help that along is by eating a bit less meat. And finally, and this is really the most important thing you can do, is make some noise. Talk about climate change with your friends and family. Make it something you care about. And there is an incredible opportunity for you to make some noise right here in Scotland, and in particular in Glasgow. Because next year, Glasgow hosts the United Nations Climate Change Summit, COP26. And there is an amazing array of things planned around this. You can have a look at some of those activities on these different websites just here are arranging activities surrounding this climate summit. And by talking about climate change, by demanding clean energy, by making this part of all of our lives, I really, really believe that we can keep making the difference that we've started making already. Okay, so finally, in terms of making some noise about climate change, and in particular here in Scotland, I was so excited to join you guys in the Barrowlands. I'd always wanted to play at the Barrowlands. I had a wee band when I was younger. It didn't clearly go very far because I'm here doing science instead, but I do still play music, and I thought I'd treat at least myself to making some noise on the main stage at the Barrowlands. So here we go. Okay, thank you very much, everyone. I'll be happy to take any questions that you have about anything that's come up in my talk or anything that you've wondered about climate change before. And I've listed up here some of those links and things and suggestions for things you can do. Thanks very much.
James Rae there, Dr. James Rae, very much the Gallagher brother of the bagpipes, playing live in the Barrowland Ballroom here for the big bounce. So, James, I was wondering, could you make your screen full? Because just get your whole face there, which is what we'd like to see.
Oh dear, sure.
We'd like to see your whole face. We do. After seeing that championship, excellent, excellent, excellent. James, I've got a couple of questions that we've got from some school children before you, but I've got a question I'd like to ask you. I've always wanted to ask a climate scientist this question, and it's this. Do you ever feel like the scientist at the beginning of a disaster film? Do you know what I mean?
You know, it's funny. It's a wonderful question, Susan. I love it, but it makes it sound really exciting. And so maybe I should, but I really don't, because I don't think that this has to be a disaster. I think that there is tremendous hope. I remain incredibly optimistic and really excited about all of the innovative and exciting things that people are doing to solve this problem. So I really want to believe that this isn't going to be a disaster. I know that it could be, right? This is serious. There are horrible things already happening, but we don't have to have those happen. We can solve this. And so I guess rather than me being the kind of scientist at the beginning of the disaster movie, what I look at is a bunch of superhero movies happening all around me. And I should say, in particular, I look at young people, the generation below mine, and all of the noise that they have made about climate change. And I look at these millions of young climate activists as superheroes who have, in the last few years, fundamentally changed the conversation about climate change. So I feel incredibly excited and optimistic about what we have the potential to do in the years ahead.
That's a shame, because I'd pretty much penciled in Mark Strong to play your role in it, and running to the helicopter shouting, "But Mr. President, don't you understand?" and then saving the planet. And I'm sure you'd be brilliant at it. Now, we have some questions, and I think we've actually got some filmed questions for you. So I think our first question comes up from, could be Liam, and let's just find out what Liam has to say.
How long will it take to fix climate change?
Did we get Liam there? Just in case you didn't quite catch that there, I have written this down because it's a small boy, and you've always got to listen very closely to small boys, because, well, I don't have to bend down very far because small boys are actually taller than I am. And Liam would like to know, how long will it take to fix climate change?
It's a great question, and there's, in some ways, quite a kind of an easy and general answer. So if you could imagine that climate change is a bit like a fire, right? You've started a fire in someone's house. Don't ever start a fire in someone's house. But imagine you see a fire that's just started. If you start, if it starts small and there's some trees or fuel, or if it's in a house, there's sofas or whatever. If there's fuel around, it will get bigger and bigger and bigger and bigger. Now, it's always a good idea to try and put out that fire. Even if it's got really big, it's a really good idea to try and put out that fire. We're going to need a whole load of fire engines to do that. We're going to need to pour on loads and loads of water. But it's never too late to do something about climate change. We always can help. But the best thing to do is to try and put out that fire as quickly as possible, because that's when it's going to be easiest to do. And so my kind of general answer to you, Liam, is we need to do everything we can as soon as we can do it, and doing things sooner rather than later makes it easier for us to fix this. It's, however, to act. Every atom of CO2 that we can prevent from going into the atmosphere helps.
So we can all help, we can all chip in, we can all make a little tiny change that would add up to a big change, so we don't wind up in a situation like Viggo Mortensen in the road pushing a wheelbarrow along with all our worldly possessions in it, which I'm quite keen on, to be honest with you, because I've got quite a lot of moisturiser. So, and we've got a second question now coming up. Morgan, I'm just checking the name, Morgan and Skye, who've got another.
How many polar bears have been saved in the last 5 years?
I want to leave the future in their hands. There was eyes of utter steadiness there in command. Morgan and Skye want to know, how many polar bears have been saved?
How many polar bears have been saved? Well, trying to get an exact number on how many polar bears we've saved already or we can save is quite a tricky thing to do. But there is a very good and kind of general and easy answer to that. And so I'm going to just quickly flick back to some of my slides again. So here are a couple of polar bears hanging out where they like to live up in the Arctic. Now, polar bears like living on sea ice. And this wee graph here shows a view from the top of the planet looking down on the Arctic of Arctic sea ice. Unfortunately, over the last 30 years or so, the amount of sea ice has decreased dramatically. And so that's not good news for our friends living up on this Arctic ice. But the good news is that, again, anything that we can do to stop putting CO2 into the atmosphere makes a difference. Everything that we can do helps. So if you're able to persuade mum and dad to change to a green energy supplier, or use the car a bit less, or just eat a bit less meat, all of those things help stop getting CO2 into the atmosphere. And as a result, they help save a few more polar bears. So doing everything you can as quickly as you can do it will help both the polar bears way up in the Arctic, but also me and you, and preventing our houses from getting flooded, preventing the flooding of tropical islands. There are all of these things that we really want to avoid in a changing climate, and we know what we need to do to avoid them.
Right, and that's great. So there was one other question, which is, do you think that we, human beings, all these people who live on the planet, really are making the connection between climate change and the devastation that's happening in places, for example, with the wildfires in California? We don't seem to be making that connection properly. Is there some better way that we can get the message over?
Well, I do. It's something that I've worried about a lot too. When you see some of those events, are we linking them back to climate change readily enough? And I think a few years ago, I'd have said that the answer was definitely no. But in the last year or two, I'm really I think the conversation has changed a lot. I think we see some of these events, really striking images of fires in California or Australia, and they do get people talking. They've certainly got people around me talking. They've changed the conversation in the news. And the other thing that has done that is young people making a noise about climate change and saying, look, this is not the planet that we want to inherit. So we can do more, but we are moving in the right direction, I think. But please, if this is something that that you have worried about, that you care about, and you'd like to see more people talking about and making a noise about, well, you can help fix this in the easiest way possible, which is just making that connection yourself, chatting about it with your friends and with your family, and just making some of these wee changes that add up into bigger changes, and then demanding that politicians, companies do the same.
James, that's great. And it's also great to hear solutions. I think so often today things are just presented as problems and that we're very helpless. But you've given us little tiny pointers and ways that we can really help and how to make a noise. Although I will tell you here and now, I am drawing the line at learning the bagpipes. Okay, so I'll leave that bit to you. Dr. James Rae, thank you so much for joining us here at the Big Bounce. And we're still here in the legendary ballroom here at the Barrowlands. We're still in the East End of Glasgow. We are back later on this afternoon when we will have the Cabaret of Dangerous Ideas. Now, don't forget to fill in your feedback form. It's at the bottom of the screen. The bottom of the screen. No, lower down. There, that's fine. Bottom of the screen. Fill that in, get into the free prize draw. In the free prize draw, you could win, are you ready for this? A scale Lego model of the Barrowlands. Who doesn't want that? So, we're saying bye-bye for a little while. You come back and join us for the Cabaret of Dangerous Ideas. I'm Susan Morrison, and catch us later. Thanks.